Next topic is projections of sections of solids. So in sections of solids, second part of the unit 2. So sections of solids draw cheyali ante definitely you must know the projections of solids component. First you have to draw the given solid in given position and then do the sectioning and then we have to complete. So what is a section? Already you completed this orthographic projections of solids. See here, when the solid object is inclined to both the reference plane, when a solid object is inclined to both the reference plane, it looks like this. So these are the hidden edges. We are representing the hidden edges with the dashed line. So as this is a simple component, we are getting a one or two hidden lines. Suppose if it is a component like this, in general engineering drawing, engineering component means you won't get a simple objects like prism or pyramid. So regular engineering components means it is having many internal features. Suppose if you represent all the internal features with the dashed lines, you may not get the clear view. Why? Because all these internal lines, dashed lines and continuous lines are intersecting or overlapping each other. So it is not possible to represent them clearly. So what we're going to do is we will cut the component with a cutting plane. So we'll simply cut the component with a cutting plane and remove one side of the cutting plane and represent only the remaining half. Now see here, if we represent a component like this, we can see all the internal details clearly. Instead of representing them with a dashed lines or like this, if you cut the component into two halves and remove one half, so you can see the internal components clearly. See the front view now. Suppose if you draw the front view for this component, the complete component, it is difficult to show these internal features. So this is the main advantage of going to sections of solids. But our syllabus is limited only up to the simple solids. And here one more example. A cone is cut by a section plane. A cone is cut by a section plane perpendicular to the axis. When a cone is cut by a section plane perpendicular to the axis, and if you remove the upper part, how it looks? The top view, you can see the base, and this is called as the section area or the section plane. Section area. And for clearly representing the section area, will represent with a parallel lines with 40 degrees inclination, inclined lines around 45 degrees. 45 degrees inclined lines to the parallel lines draw chesi represent means this is the region where the cutting plane is cutting the solid. So this representation is called as the sectioning or hatching. Alage cutting plane representation koda, it should be with H pencil and ends must be with HB. Ends dark cheyali. And this is not the axis line. Axis line in the representation long dash and dot. Axis line representation is long dash and dot. But cutting plane representation is long dash and small dash. Long dash and small dash. Or long dash or two small dashes. Better go with this representation. The cutting plane always must be represented with long dash, two small dashes, and edges ni thick cheyali means edges ni HB to highlight cheyali. So these are the various examples for sectioning. Already we discussed this while discussing it in the conic sections. So when a cone is cut by a section plane, passing through the apex point and the base, will get a triangle shape. When you cut with a plane inclined to the axis, you'll get this section area ellipse. When you cut it with a plane parallel to the one of the generators, parallel to the generators, and by cutting the axis, we'll get a parabolic shape. And when the section plane is not intersecting the axis and only passing through one side of the cone, we'll get a hyperbolic shape. Similarly, for a cylinder and a square prism pyramid. These are the various examples for sectioned solids. Now, the section plane can be at different position. So the possible positions are section plane can be parallel to horizontal plane and perpendicular to VP. The section plane can be parallel to HP and perpendicular to VP. The section plane can be perpendicular to HP and parallel to VP. So, ఈ two cases ఏమవుతుందంటే when the section plane is perpendicular to VP, in front view you can see the section plane as a line. When the section plane is perpendicular to HP, the top view looks as a line. Similarly, the section plane is inclined to HP and perpendicular to VP. So here similarly, as it is perpendicular to VP, in front view, the section plane is represented as a line. Similarly here, when the section plane is perpendicular to horizontal plane, the top view, in top view the section plane is represented as a line. So here it is perpendicular to VP and inclined to VP and perpendicular to HP. So these are the four possible options for any section plane. So మనం ఐడెంటిఫై చేయాల్సింది ఏంటంటే in which view you can see the section plane as a line. A view లో section plane line లాగా represent చేయగలం. When the section plane is perpendicular to vertical plane, in front view it looks as a line. When the section plane is perpendicular to HP, in top view it is represented as a line. So you should remember these two conditions. So this is one more example. When the section plane is parallel to HP and perpendicular to VP. When the section plane is, this is the section plane, blue color line. So when the section plane is parallel to HP and perpendicular to the ground, first step is you have to draw the projections of the pyramid as usual. After completing the projections of the pyramid, the section plane is drawn at the given position. So as it is perpendicular to the VP, it looks as a line in front view. Front view lo line la kanpadutundi. So this is represented as a line. Note the first problem. I'm giving you time. Note the first problem in sections of solids. And I'm going to explain this complete topic through PPT only. I will share this PPT after completion of the class. Meanwhile, note on the problem. A pentagonal pyramid of base 30 mm side and axis 65 mm long has its base on HP and an edge of base parallel to VP. It is cut by a section plane at a distance 25 mm from the base. Draw its front view and sectional top view. Draw its front view and sectional top view. So first, note on the important points from this. First of all, what is the object, shape of the object? The shape of the object is pentagonal pyramid with a base on HP. Next, edge of the base parallel to VP. Edge of the base parallel to VP and section planes. The first 3 points, these are the points representing the position and shape of the component. And coming to the section plane, the section plane position is given as parallel to HP, perpendicular to VP and 25 mm above HP. As it is perpendicular to VP, in front view you can see the section plane as a line. So front view lo section plane you can represent it as a line. Next we'll go for the top view representation. Similarly, coming to the component, it is a pentagonal pyramid with a base on HP. Pentagonal pyramid with a base on HP. So when the base is on HP or parallel to HP, in which view you can see the true shape of the base, front view or top view? Answer change. When the base is on horizontal plane, in which view you can see the true shape of the base?
Front view, sir.
Front view ఒకసారి చూడు నీ చేతిలో ఉన్న కాంపోనెంట్ ని పొజిషన్ లో పెట్టు బేస్ Can you see the video? I'm switching on this video. See, if you see the video, when the component is perpendicular to the base, when the component is or when the base is parallel to ground, when the base is parallel to the ground, we can see the true shape in top view. Top view lone true shape కనబడుతుంది. In front view only you can see this triangular faces. Only on top view you can see the true shape of the base. Now first draw the XY line and true shape of the base. True shape of the base draw చేసేప్పుడు కండిషన్ ఏమి ఇచ్చారు? Edge of the base parallel to VP, base on HP and an edge of the base parallel to VP. So you must draw in top view a pentagon with an edge of the base parallel to VP. So as it is a pyramid, join all the base corners to the apex. In top view you can see all the 5 triangular faces. These 5 triangular faces are visible in top view. So you must draw these lines with HB and complete the dimensioning also. Now, after completing the projection of top view, draw the projections from top view to front view and complete the front view. Observe this in front view. As you are seeing the component in this direction, point A is visible, B visible, C visible. D and E points are hiding. These are on the other side of the observer. So points D and E are hiding. So the lines joining DO and EO must be drawn with dashed lines. So with this we completed the projection of solid. We completed the projection of solid. Now coming to the section plane. The section plane is perpendicular to vertical plane and parallel to the ground. Is it? The condition is given as the cutting plane is perpendicular to the axis or perpendicular to the vertical plane. When the cutting plane is perpendicular to the vertical plane, we can see it's as a line in front view. Front view lo line కనిపిస్తుంది. Top view a complete plane surface. So front view lo line కనిపిస్తుంది కాబట్టి we'll first draw it as a line in front view in the given position. That is, from the base, it is at a so draw a perpendicular line to the axis at a height of 25 mm from the base as given in the problem. So the section plane looks as a line in front view. Now the section plane is cutting all these slant edges. This is the section plane. The section plane is cutting the slant edges AO, BO, CO, DO. Mark all these points as 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. See here, the section plane is cutting AO at 1 dash, BO at 3 dash, DO at 4 dash, EO at 5 dash. Now mark these 5 points 1 to 5, 1, 2, 3, 4, 5 points on top view. So project this, draw a projection from 1 dash. 1 dash is a point on A dash, O dash. So project this 1 dash up to AO line. Project this 2 dash, for we'll discuss the 2 dash later. Project the 3 dash. 3 dash is on CO up to CO line. 4 dash is on DO up to DO line. 5 dash is on EO, so up to EO line. What about 2 dash? 2 dash is on BO line. So if you draw a projection, you are not getting a specific point. You are not getting any specific point. So for this, what we have to do is project this 2 dash to the extreme plant edge, either to left or right. Mark this point as 2 1 dash. Draw the projection from 2 1 dash, a parallel line to XY line. So 1 dash and 2 1 dash are coinciding. You'll get a point 2 1 dash. Actually, this is 2 suffix 1, not 21. 2 1 dash point. Now draw the projection from 2 1 dash to 1 point in top view. So after getting this 2 1 point, measure the distance from O2 to 1. Measure the distance from O2 to 1 and draw an arc with radius as O to 1 and center as O. Draw an arc. We'll get a point 2 on the slant edge OB. Join 1, 2, 3, 4, 5 with continuous lines. Now, this is how it looks when it is in top view. This is the sectional top view. And this section is represented with 45 degrees inclined parallel lines, and maintain this distance between lines 4 mm or 3 mm. So equal distance maintain. Be careful. These lines must be parallel to each other and equidistant, and a line to line measure distance maintain 3 mm perfectly, so that you will get accurate or neat shape. And as you are removing this portion, these lines are represented with 2H. Only means first initial gain challenge, draw the entire top view with 2H pencil and only highlight the retain. And even in top front view lo koda, we are cutting the component with section plane and removing the top part. So only the base must be represented with HB and remaining top part must be represented with 2H. You must show this difference. Then only it shows which part is retained and which part is eliminated. So represent the upper part with 2H and the part between section plane to XY line with HB. So this is how to draw a projection a section of a solid. The first problem. So do any of you are having doubts in this?
సార్ 3 mm గ్యాప్ తో గీయమన్నారు కదా సార్, అవి ఎన్ని నెంబర్ ఆఫ్ లైన్స్ అనే ఏమైనా కౌంట్ ఉంటుందా?
కౌంట్ లేదు, జస్ట్ ఫిల్లింగ్ దిస్ ఏరియా. ఈ కంప్లీట్ ఏరియా అంతా కూడా ఫిల్ అవ్వాలి. సో ఒక కార్నర్ నుంచి స్టార్ట్ చేసి డ్రా ప్యారలల్ లైన్స్ టిల్ యూ రీచ్ ద అదర్ ఎండ్. స్టిల్ ఇంకేదో డౌట్స్ ఉన్నాయా? సో గుర్తుపెట్టుకోండి, if you are attempting a section of solid problem చేస్తున్నాము అంటే we are including projections of solid and a projection of a plane concept also in this. But compared to the previous two, ఇది కూడా కొద్దిగా ఈజీగా ఉంటుంది, ఎందుకంటే our syllabus is limited only to the simple positions. Simple positions లో restricted syllabus, so you'll get only the simple problems. Next, note the problem 2. Go through the problem. hexagonal pyramid. So most of the cases you'll get only the problems on pyramid. ఎందుకంటే if you cut a prism perpendicular to the axis, you'll get almost the same shape even after sectioning. So most of the examples they will be on pyramids or cone. So read the problem number 2. Hexagonal pyramid of base side 25 mm. Hexagonal pyramid of base side 25 mm and altitude 55 mm means length of the axis is 55 mm, rests on its base on horizontal plane with two of the base edges parallel to VP. A cutting plane parallel to HP cuts the pyramid at a height of 25 mm above the base. Just for comparing, of first 4 or 5 problems, I have given the same cutting plane. In all the problems, we have chosen such that the cutting plane is parallel to HP and perpendicular to VP and the same distance, that is, the cutting plane is at a height of 25 mm above the ground. Even if you compare the previous problem to this problem. The shape is hexagonal pyramid with a base on HP. So when the base is on HP, you can see the true shape in top view. So top view though, we must start the problem. So in top view, how to draw? One more condition is given. Two of the edges parallel to VP. Two of the edges parallel to VP. Two of the base parallel to VP. And coming to the section plane, parallel to HP, perpendicular to VP and 25 mm above HP. Actually, the condition perpendicular to VP is not represented here. So if you try to keep a plane parallel to HP means definitely it will be perpendicular to VP. Now, this is how it looks. I'm not explaining step-by-step process. Why? Because these two problems are of the same condition. Both are pyramids, section plane at the same distance. Only varying is previous one is a pentagon and this one is a hexagon. So they follow the same sequence of steps. First, draw the hexagon with two of the base edges parallel to VP. So draw the hexagon with two of the base edges parallel to VP, top view, and then draw the projections to front view, complete its front view shape. So after drawing the front view, draw the section plane. The section plane is perpendicular to VP. As it is perpendicular to VP, in front view it looks as a line at a distance of 25 mm from the base, a line. Mark the intersection points as. The section plane is intersecting these slant edges as at 1, 2, 3, 4, 5 and 6. See here, FO and BO are hidden edges. So 5 and 6 are represented within the brackets. Means these two are hidden points in front view. Similarly, F and E as hidden points. So after marking this, draw the projections from each and every point 1, 2, 3, 4 from front view to top view, and mark the points in top view also 1, 2, 3, 4, 5, 6. After marking these 6 points, join them with a straight line and complete the hatching. See, observe here, as we are cutting the pyramid at this position and removing the upper part is represented with 2H and the bottom part is highlighted with HP. See the difference. You must show this difference clearly. Similarly, in top view, the internal lines hatching, draw the hatching with HB, but these lines as it is we are eliminating. So represent these lines with 2H. The lines joining to 2O, 3O, 4O, 5O, 6O, 1O. We must represent this with 2H. So front view, and sectional top view. Coming to the third problem. Note on the third one. Can you draw the second problem? Or do you need any more explanation? As first and second problems are of same type, only variation is there it is a pentagonal pyramid, here it is a hexagon. I'll not explain step by step process. Do you require step by step process?
సార్ ప్రొజెక్షన్ గీసినప్పుడు చెప్పండి.
Projection drawing. Okay. So as the condition is base on HP. So base on HP under kabatti, we must draw the top view first. So top view atla with the two of the edges parallel to VP. Two of the edges parallel to VP condition, so draw the hexagon. And then join these lines. As it is a pyramid, all these lines are visible. Join the lines from base corners to the apex. Base corners to the apex. Okay, join cheyandi. Now draw the projection. As it is resting on its base on horizontal plane, project A, B, C, D, F points up to XY line. XY line varaku project chesi draw the base. And then project the axis, draw the axis line. Draw the apex line, axis line to the given height 55 mm and mark the endpoint as apex O dash. So after getting the base and apex, join all the base corners to the apex. Join AO, BO, CO, DO, EO and FO. And as this is the viewing direction, when you are viewing the hexagon in this direction, E and F points are hiding. So EO, FO are hidden lines. But EO, FO edges are overlapped with BO and CO. No need to represent as dashed lines. So after drawing the front view and top view, section plane, as it is perpendicular to VP, it looks as a line in front view. So front view line. And where is the position? It is cutting the axis at a height of 25 mm from the base. So axis nunchi 25 mm height lo draw a parallel line to XY line. This line is intersecting all the slant edges. Is it? It is intersecting the slant edge AO at 1 dash, BO at 2 dash, CO at 3 dash, DO at 4 dash, EO at 5 dash, and FO as 6 dash. Now project all 1 to 6 points. As 1 dash is on AO line, project 1 dash up to AO. 2 dash is on B dash O dash. So project 2 dash up to BO line. Similarly, project 3 dash up to CO line. 4 dash up to DO line. 5 dash up to EO line and 6 dash up to FO line. Mark these points as 1, 2, 3, 4, 5 and 6. Join them with the straight lines and then complete the hatching. Is it clear now? Doubt clarify in the.
Okay, sir.
Go through the next problem. Problem number 3. A cone of base diameter 40 mm and altitude 50 mm. A cone of base diameter 40 mm and altitude 50 mm rests on its base on horizontal plane. It is cut by a plane parallel to HP and 25 mm above the base. Same as the previous problem. Only thing, it is a cone. The same condition with its base on HP and section plane parallel to HP, perpendicular to VP, 25 mm above HP. So first draw the cone. First draw the cone. Top view of a cone is a simple circle. A simple circle. and divide it into 4 parts, 2 diameter lines, horizontal and vertical lines. Name the corners as A, B, C, and D in top view. After completing the top view, a simple circle with 4 diameter endpoints A, B, C, D. Draw the projections to front view. As it is resting on its base on horizontal plane, draw the projections from A, B, C, D up to XY line in front view. On XY line, represent it as A dash, B dash, C dash, and D dash. And as you're seeing in this direction, A, B, C are visible. The point which is on the other side of the observer is hiding. D dash as hidden point. Now draw the axis line, mark the apex point O dash. Draw the only two outermost generators. Join AO and CO. Join AO and CO. And here as we require, this is BO and DO. Now, the section plane, as it is perpendicular to VP, it looks as a line in front view. It looks as a line in front view. So front view low, 25 mm above the horizontal plane. Draw a parallel line. And this sectional plane is cutting the generators AO at 1 dash, BO at 2 dash, CO at 3 dash, and DO at 4 dash. So after getting this, as DO is hidden line, so 4 dash is also a hidden point in front view. As 1 dash is on AO line, project it up to AO line. Similarly, 3 dash is on CO line, project it up to CO line. Now, for getting 2O and 4O, so as it is a cone and the section plane is perpendicular to the base, the sectional view is also a circle. So ఏం చేస్తారంటే O as center, O1 radius తో draw a complete circle. O as center and O1 radius తో draw a complete circle and mark these two intersection points as 2 and 4. Complete the section. Better I will stop at this point. Next class we will discuss the remaining. Why? Because by coming to next class, practice these 3 problems. Okay, better practice this cylinder also. And we'll discuss this next problem in the next class. So before coming to next class, practice these 4 problems completing. So sheet submission also లేదు కదా నొద్దు. So మీరు once practice చేస్తేనే you will understand the difficulty or you will get the doubts. మీ డౌట్స్ వచ్చినాయి నెక్స్ట్ క్లాస్లో అడగొచ్చు. So before coming to next class, complete these 4 problems. Okay. So next, cylinder. Cylinder with 50 mm base diameter and axis 60 mm long is resting on its base on HP. మీరు అబ్జర్వ్ చేస్తే 4 problems లో almost the same similarity, only variation is the shape of the object is varying. Section plane and the remaining process, everything are same. Only thing is the shape of the component is varying. So in a day, as I want to introduce the concept, I'm discussing these 4 basic problems with the similarity. Cylinder with base on HP, and again the section plane parallel to HP, perpendicular to VP, 25 mm above HP. First draw the cylinder. Cylinder when it is resting on horizontal plane, top view as a circle. Draw the top view as a circle. Mark the endpoints A, B, C, D on one base, P, Q, R, S on the other base. So cylinder kabatti you are having top base and bottom base. On one base A, B, C, D corners, and on the other base P, Q, R, S. So project this to the front view. So one base on the ground. So ఇక్కడ ఏం రిప్రజెంట్ చేసాం PQRS are heading. So PQRS on XY line, ABCD on the other base. So first bottom base draw chesi 60 mm height project chesi complete this rectangular outer shape. Rectangular outer line. Now the section plane is 40 or 25. So actually figure లో 25 ఉంది. Take it as 40 ఉంది. Take it as 25 తీసుకోండి. So here also the section plane is perpendicular to the vertical plane. So the section plane looks like a line in front view. So front view లో section plane cut చేస్తే so remaining part about the remaining part also looks like a circle cylinder, is it or not? Whenever a cylinder or prism is cut by a section plane parallel to the base, remaining component kuda having the same shape. Pyramid lo laga, you are not getting the different shape. Only variation is the height is reduced. So where the section plane is cutting, section plane is cutting the edges. A dash P dash at 1 dash, B dash Q dash at 2 dash, R dash C dash at 3 dash, and S dash D dash at 4 dash. But ikkada, if you project these points, AP as a single point undi. Actually, AP is a line looking as a line in front view. But in top view, AP is at a single location. So, 1 point akkade coincide avutundi. 2 point, you'll get it at BQ 0.3 here, and DS దగ్గర will get 0.4. So the complete surface అంతా కూడా కట్ అవుతుంది. So the complete top surface is hatched. Surface అంతా కూడా hatching చేస్తాం. So you'll not get a separate section plane here. So 4 problems. Before coming to next problem, draw these 4 problems. Next class we'll solve the problem when the section plane is parallel to vertical plane and perpendicular to horizontal plane. The section plane parallel to horizontal plane and perpendicular to horizontal plane, and the solid is in the same position with the axis perpendicular to HP. Okay, I'm concluding this. So before coming to next class, practice these 4 problems and also complete the projections of solid sheet also. So projections of solid sheet draw chestene you can understand the sections of solids. Why? Because sections of solids, so starting it with projection of solid, drawing the component in the given position.